geometric sequence is a list of numbers, and suppose that we call the first a geometric sequence is a list of numbers where there's a common ratio between terms. So suppose that we call the first term A and the common ratio R. Then our geometric sequence will be A, AR, AR squared, AR cubed, and so on. Each time we get the next term by multiplying the previous one by R. Now a geometric series is the sum of some of the terms in a geometric sequence, consecutive terms. So if we write Sn for the sum of the first n terms, note that it goes up to n minus 1 because we start with a times r to the 0, we have this formula. Now, by means of a neat trick, we can come up with a much shorter formula than this for Sn. So let's see where it comes from. Suppose that we write down underneath r times Sn is equal to AR plus AR squared plus AR cubed all the way up to AR to the n minus 1 plus AR to the n. So this term has been multiplied by R, the previous one has been multiplied by R, this one's been multiplied by R, and so on. A lot of the terms in this series are also in this series, so let's subtract them. And this term will be cancelled off by this one will be cancelled off by this one by the next one, and so on when we subtract, except the n terms. So we'll be left with a times r to the n minus a. So already it looks simpler, but to get Sn on its own, let's take out a common factor of Sn and write it as Sn times r minus 1 is equal to, and then on the right again take out a common factor of a times r to the n minus 1. Now, if we divide through by r minus 1, we'll find that Sn is equal to a times r to the n minus 1, all divided by r minus 1. So this is the formula for the sum of a geometric sequence and the first n terms of it. Okay, so let's do an example. Suppose that we'd like to find the sum 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. Let's see if we can use this formula to help us. So the first term, a, is equal to 1. The common ratio between terms is 2. So we can say that S8, which is what we'd like in this case because we've got 1, 2, which is 1, times r to the n, which in this case is going to be 2 to the 8, minus 1, all divided by r minus 1. If we worked out 2 to the 8, it would be 2 times 128, which is 256, minus 1 over 1. So I can say that my answer is 255. It's also worth just pointing out that this Sn equals another way of writing Sn, meaning the sum of these terms, is to use the Greek letter sigma and to say that we have an index I that runs from 1 to n, and each term has the form ar to the I minus 1. So when I is 1, we have a times r to the 1 minus 1, which is a times r to the 0, which is just a. When I is 2, we have a times r to the 2 minus 1, which is just a times r, and it runs all the way up to I equals n. So we get a times r to the n minus 1, which is the final term in this line here. So this is an alternative piece of notation for the sum of a geometric sequence or a geometric series.